Hello and welcome. We're going to dive into a question you've probably never even thought to ask. How does your computer actually talk to the printer sitting right across the room? I know, it seems so simple, but the way it all works is honestly fascinating. So, let's get right into it.
Think about it. It feels kind of like magic, right? You hit print, and somehow, out of all the devices in your house or office, your document finds the one correct printer. How on earth does it know where to go? Well, it's not a magic, it's networking. And we're about to pull back the curtain on how it all works. The whole story of how your devices chat with each other starts in one place, the local area network, or as you probably know it, the LAN. You can think of this as your computer's immediate digital neighborhood.
So what is a LAN? Well, it's pretty much what it sounds like, a local network. This could be your Wi-Fi network at home, or it could be all the computers plugged into the wall in your office. The key thing is, they're all part of the same digital community, and they can have a direct conversation with each other. Now, in the simplest kind of LAN, all the devices are hooked up to a single shared channel. This image here shows it perfectly. Just imagine every computer is on the same old-school party line telephone. This idea of a shared connection is totally central to everything that's coming next. So, because everyone's on this shared line, when one computer sends out a message, every other device on that line hears it. It really is like shouting in a crowded room. And this brings up a huge question right away. How does any device know if a message is actually meant for them? To solve this shouting in a crowded room problem, every device needs a name. But here's the twist. They actually need two very different kinds of addresses, and they have to work together to make sure messages get to the right place. Okay, so you've definitely heard of an IP address. Think of it like your house's street address. It's what's used to get data across the entire internet to your neighborhood. But for the local mail carrier to get a package to your actual front door, you need something way more specific. On a LAN, that specific thing is the MAC address. It's this permanent, unique serial number that's literally burned into your device's network card. It's like a digital fingerprint. No two are alike. So every single message that gets sent across the LAN gets packaged up inside this digital envelope. It's called an Ethernet frame. Doesn't matter if it's a huge print job or just a tiny bit of data, it gets wrapped up in one of these before it heads out the door. And if we peek inside that frame, the two most important parts for local delivery are the destination and source MAC addresses. So when a device on the network sees a frame whizzing by, the very first thing it does is check that destination address. If that fingerprint doesn't match its own, it just ignores it. It's not for me. Problem solved. But wait, this brings up a whole new puzzle, doesn't it? Your computer usually knows the printer's IP address, but for that local delivery, it needs the MAC address. So how does it figure out the printer's MAC address to slap on that digital envelope in the first place?
Right, so your computer knows the printer's IP address. Let's say it's 192.168.1.100, but that's just the street address. It's not enough. It needs that MAC address, that fingerprint, to make the final delivery. So what does it do? Well, it basically has to ask for directions. This is where a really clever process called the Address Resolution Protocol, or ARP, comes into play. You can think of ARP as the LAN's very own information desk. Its entire job is to translate an IP address, which we know, into the MAC address, which we need. So here's how it works. Your computer sends out a special message called an ARP request. And as you can see, the destination is set to broadcast. This is the digital version of shouting into that crowded room. Hey everyone, who here has the IP address 192.168.1.254? Can you please tell me your MAC address? Now, every single device on the LAN hears this request, but only one of them recognizes the IP address and says, "Oh hey, that's me." And here's the cool part. This device, our printer, it doesn't shout back to the whole room. It sends a direct private message right back to the computer that asked, saying, "Yep, that's me. Here's my MAC address." And just like that, your computer has the fingerprint it needs to send that document directly to the printer. Okay, so we've got the addressing figured out, but what about the actual hardware that's connecting all these devices together? Well, in the early days of networking, the most common solution was simple, it was cheap, and it was very, very noisy. Meet the hub. A hub is basically a simple digital repeater. It doesn't think, it just acts. When a signal comes in on one of its ports, the hub just blasts a fresh copy out of every single other port. It's the physical piece of hardware that enforces that shouting at everyone model we've been talking about. As you can probably imagine, this caused some major problems. First, it wastes a ton of bandwidth because every computer has to waste time looking at traffic that isn't even for them. But more importantly, it creates what's called a single collision domain.
If two devices try to talk at the exact same time, their electrical signals literally collide on the wire and get scrambled. The whole network has to stop, wait, and then try again. It was a mess. Clearly, the network needed an upgrade. It had to evolve. It needed to go from being a loud town crier to a smart, efficient switchboard operator. It needed a device that could create private, one-to-one conversations. And this slide just shows that evolution perfectly. On the left, you've got the hub, blindly broadcasting everything. But on the right, you have the switch. A switch looks at the destination address on an incoming message and intelligently forwards it only to the single port where the destination device is actually connected. No more shouting. So, how is a switch so smart? What's its secret? Well, this is the really clever part. A switch is a learner. As it sees data arrive on its ports, it reads the source MAC address from each frame and starts building this little internal map or table, making a note of which device lives on which port. Just take a look at this table. When a message from the MAC address ending in 9693 comes in on port 1, the switch makes a little note. Got it, that device lives on port 1. Then, a message comes in on port 4 from the device ending in 5D-FE. It adds that to its map too. Over time, it automatically learns the location of every active device on the network, all by itself.
This learning ability completely revolutionized local networks. It's what allows for direct, point-to-point communication. It gets rid of those collisions because each port basically becomes its own private line. The whole network becomes incredibly efficient because all that unnecessary chatter is just gone.
But even a smart switch has one limitation. It's designed to be helpful, so when it receives a broadcast message, remember those ARP requests we talked about? It does its job and forwards it out to everyone. When it's asked to shout, it still shouts. This means that an entire switched network is still one big broadcast domain. So what happens when you want to connect your network to another one, or to the entire internet, without all of their broadcast traffic flooding your devices? How do you create boundaries between networks? Well, that is a job for a completely different device, a router. And that is a story for our next explainer.